Hi, everybody. This is the Kubernetes SIG architecture meeting for Thursday, September 7th. And looking at our agenda, first item is the kubelet API. Looks like there were, okay. So I actually haven't been following this. I just before the meeting looked at the document here, but looks like there's been some discussion previously. Maybe I missed a meeting or two. But yeah, Rob or
So yeah, this is Katarzyna and I are proposing this, and Katarzyna probably has more context. We discussed this in the last SIG architecture meeting as well, and also have discussed this in SIG node meetings a couple times now. This is again the idea for anyone who may have missed that context is that we're trying to take information that's already on the node and originating from the node and expose it locally. So again, from the networking side of the world, we would sure love to know the health of the pods on the same node as us without having a control plane dependency getting in the way of that. So if control plane is down, we don't want to cause unnecessary downtime for customers, whoever, if we can't update readiness because control plane just isn't available. It just seems like an unnecessary dependency. This felt relevant to both SIG Arch and SIG Node, which is why we're here. These are some very rough meeting notes I took from our last trip to SIG Arch a couple weeks ago. Katarzyna has added the content in blue, which is an attempt to answer those questions. But maybe Katarzyna, I don't know if you want to provide any more context or any like key details that you think we should discuss today. You're muted if, or maybe not. Actually, you're not muted, but I can't hear you.
I can't hear you either. Yeah.
Still nothing. Okay. All right. Well, I'll keep on talking then until I hear
Maybe
you.
now?
Yeah,
Yes.
perfect.
Okay. Sorry, guys. Yes, so on the last meeting, we present this kubelet API, and there was a lot of questions, comments, and open questions. So, like Rob said, we wanted to, address them right now. So maybe starting with the gRPC, maybe this is the end. So there were questions why we choose gRPC, not REST API. And actually, the kubelet exposed REST API with a read-only and authorization port. And read-only port, and there was this endpoints, for example, pods. So you can see that there was some need to expose data directly from the kubelet. But actually, on many clusters, the read-only port is being shut down due to security reasons. And the only way to access this endpoint is to use authenticated port, and the authentication is going through the control plane. So if you want to achieve the locality, if you want to reduce the dependency on control plane, using authenticated port is not like the best idea. And actually, the API is designed to be accessed for log world running on the node. So we want to achieve this locality. So gRPC and using unique socket will be for us good to, enforce this locality. You can say that. Also, gRPC is strongly typed and versions. So it'd be using version, we can introduce some new, let's say, things or changes, and we can, let's say, change this API in the future like this. So this is the answer.
You've described a particular HTTP server, but not really addressed a general HTTP server, right? So you've described an HTTP server that goes to the control plane. But it doesn't have to be an HTTP server that goes to a control plane, right? The choice between HTTP and gRPC is different than a choice about how you go, how you handle authentication and authorization.
Yes, but so maybe I'm not. Yes, but still, there were two ports. One was read only, and the port is open on the node, right? So it's really hard for workload to pretend this API, which already exists in kubelet, to be accessed only within the node with this read-only port, but not from outside. So that's why we choose.
David's point is that we can differentiate between whether we use a Unix socket or a network port from whether we use HTTP or gRPC. So like, it's clear that using a Unix socket is probably the right path for this kind of API, at least to me. But you could run an HTTP server on that, or you could run a gRPC server on that. It doesn't matter. So those are different questions. That's his main point. So, I mean, I can definitely see the argument of gRPC is versioned and has, you know, a bunch of schema-based things that allow backward compatibility and all of that. But we also have some of that in our HTTP REST API for Kubernetes, but it's bringing in a whole lot of baggage. So I don't know. It's, yeah. Is that your concern, David? Is that clear? Did I clarify that?
Yeah. So that's the difference between the existing HTTP server and if you're already creating a new server, like why choose one over the other? It wasn't clear to me that like gRPC has better client support overall. Maybe it does, and I'm just not aware of it. But I definitely think of gRPC as take this action versus read these.
No, it's message passing. I mean, it's actually really nice for like, so if you think about gRPC, first of all, is HTTP. So it's just on top of that, right? It's more about the marshaling and the sort of the schema and the way that it's described, and it's got streaming and versioning, and you can add and remove, fields and whatever, with a lot of tooling to support that we have, for example, all of this versioning support in our RESTful Kubernetes API machinery and schema infrastructure. So I don't know. Like, I'm not giving an opinion one way or another here, but definitely gRPC is not just a do this type of thing. It's got very rich schema support.
Two questions that might be helpful to answer would be what are the clients we envision using this? Are they the same clients that are using other gRPC APIs on the node today, like the pod resources API or some of the container CRI gRPC APIs? Are they the same? Is that the level that the clients we're expecting to interact with this API are?
Yes, mostly those going to be the clients that's going to be the workload that's like system pods, which are running on the nodes. And yes, they are, let's say they are already using, for example, would like to switch from using Kube API to using something local. They are using gRPC.
Okay. It would, if the clients that we primarily anticipate making use of this are already generally gRPC oriented, whether they're talking to CRI or CSI or pod resources or device plugins, that's a useful data point. gRPC is probably going to feel more natural to them. Just from my perspective, maybe from David's as well, being not as familiar with all the things gRPC can do and do well, like an example of what it looks like to do streaming with gRPC would be helpful. Like I know we have that in the REST APIs for Kubernetes, and it was kind of a pain to build. If gRPC handles that sort of natively automatically, and that's really nice, then it wouldn't bother me to make use of that. But if we're going to have to re-implement it in a sort of painful way on gRPC as well, then I wouldn't want to do that. So just an example of like, what does streaming look like with gRPC, and is there good client support for that? Is it easy? That would be helpful for those of us who are less familiar with gRPC.
Okay, so I will add this to the doc. Yeah.
No, go ahead. I was just gonna say, for what it's worth, I mean, I haven't used gRPC in a while, but it was super easy when I did it back in the day. So.
Okay, and with gRPC was also consideration about the authorization. And actually, so the thing is that we want to limit this API to the node. So we think that doing the authorization and authentication, it's not needed here. And we'd like to design the API in this way that the data that are exposed can be seen for all of the workloads on the, let's say, can be seen for all the workloads on the nodes. So it's gonna be not, that's why we want to do small functions like this conditions, that it's not gonna be harmful to expose some too much data, like for example, exposing the whole pod spec, that we want to limit those data. And with this idea, we want to design and then evolve this API. Does it make sense?
I think I understand the claim. I think that once you create an API, even if it's acceptable or accessible only on a single host, it's hard to assume that every client would be allowed to see everything. Right? I mean, I guess like we know that's not true on many clients today, right? You can't see. Imagine you add another client. I know you say it's just CNIs, right? But like, what if you add something for CSI? It seems like a natural thing. I want to see the pods here. But a CSI driver would only need to be able to see the pods that had its CSI volumes, right?
So I think, David, the question is, I think there's already prior art around exposing some local gRPC APIs. And I'm curious what we do today for authentication and authorization on those, if anything. I think it's basically controlled by Unix permissions, which is pretty lame, but pretty non-granular, I should say. Is that accurate, Katarzyna? Like, I seem to recall there being other existing APIs, and I see, was it Antonio? Somebody put in the like device plugins do something similar today.
So the pod resource, I think this is the endpoint for device plugin. I just okay, so I didn't really check the authorizations they're doing. I don't think there's yeah, I don't think they have. But still, the authorization needs to go through kubeAPI, because I don't think that we want to do, copy and do the same thing inside the kubelet. So still, if you would like to do any authorization, we need to go through kubeAPI, right? From control plane, right?
Well, so
it depends on what authorization you need. Like if the authorization is all or nothing, it's can you access this API at all or not at all, then just like Unix socket permission is sufficient. If you want to expose multiple APIs on a single socket and then say you can access this one but not that one, this one but not that one, then like you need something beyond sockets. And then if you want to go further and say you can access some pods based on some attribute, like what namespace they're in or whether they have your CSI volume or like some attribute, then that's an even further level. It doesn't necessarily have to go to the API server, but you have to define that permission somewhere, and doing it node local seems really fiddly.
Yeah.
The comment about not containing any sensitive information, if we're not exposing like pod specs and like environment variables and stuff like that, that's good. Annotations and things. I wonder, like, if each new client of this will need a little bit more information. So maybe what you need is just like the pod UID and the conditions, or the readiness state, right? So you could probably make a case that there's not sensitive information in there, although reasons about conditions maybe, but probably not. But like annotations are used to plumb sort of random information to random things pretty frequently. And so things like annotations on pods, I could easily see a client saying, oh, well, I need the annotations because that's how I get the information about this attribute or that attribute or whatever else. And then something else going, oh, but no, I put sensitive data in the annotations. I mean, in the case of client-side apply, like the full pod spec is sitting there in an annotation. So like sort of thinking about how we would get the information to the clients that they need without letting it contain sensitive information, I'm not sure about that as this evolves.
Yeah, I totally agree with the annotation. That's why we are focusing on these data that actually are computed by kubelet, and they are like, let's say, purely computer. Like, for example, condition. So the readiness, it's like can be used. So this is a read-only port. So so there might be various reasons why Workflow wants to see whether pods are ready or not ready. But yes, like you said, it's gonna be hard when this API evolve. But I mean, this API doesn't really need to be very big. I understand that people would, when there is an opportunity for the local endpoint, people would like to add some new stuff. But actually, when I think that it is really needed, this locality, that not everything needs to go through Kube API, and also Kube API has limitation that, for example, we can query the whole pod spec or the whole pod status, and for some on node, let's say, workloads, fetching to those too big structure might be unnecessary. They might unnecessary with a lot of resources. That's why we started to think about this.
I guess taking the current authorization capabilities of Kube API server as a point of parity might be a reasonable claim. Like today, if you want to give something running on the node the ability to see pods, nodes run pods across namespaces. So you can't bound it to just one namespace. You can't limit authorization to just the pods on that node. Like there's actually no way to give something the ability to get pods from the node today limited to just nodes with a particular CSI volume or something. So like if this is saying like we don't need to be more granular than the Kube API server is in our authorization here. And the point of this is to largely make it available when the Kube API server is not available. Maybe saying the scope of this is pods on this node, and we'll limit ourselves pretty much to the status the kubelet computes, not including user specified values. Maybe that's okay. I can believe that, like if Kube API server doesn't support those authorization levels today, making this support those is kind of unreasonable.
Yeah, one thing about authorization that we discussed in Bruno this API, and the problem right now is we have pod resources API, and for pod resources API we create the default throttling threshold. So if somebody abuses API, then like every user of this API will be affected. Due to lack of the authorization, we don't know who calls this API, so we cannot restrict one client and like throttle per client or something like that. So this API will have the same problem. Like if you don't have any client authorization, then we cannot do per client throttling. So noisy neighbor problem will be may be relevant and may appear for this API, especially if it's becoming more and more popular.
Yeah, I mean, you can control it
like
by Unix permissions. Sorry, Jordan. What?
Do we really think this is going to be like a super popular API, or are we imagining like a network plugin and a couple storage plugins on the node? Like I'm not anticipating hordes of people writing to this API.
I would assume many monitoring agents will want it.
Yeah, but you can always cache the information and read it. I mean, we are doing that with the etcd props and all this.
Okay, let's continue on the questions. I feel like we don't have so much time.
Yeah.
Let me see, where were we?
Okay, so next question was about the static pods. So yes, we think the static pods should be included, but we should mark it that this is the static pod. So user is aware of those, you know, from that this is static or not static pods. And mostly was also concerns about the corner cases. And there are a few corner cases. For example, what if kubelet is restarting? There's this kubelet restarting issue, and there is this control plane unavailability issue. So with kubelet issue is the thing is that when kubelet restarts, so first of all, kubelet needs to read some information from control plane kube API, and then kubelet needs to run, let's say, initial loop to. I'm sorry, but I can hear myself. Okay, sorry guys. Okay, so then kubelet needs to run the initial loop to know about each pod, and by the time the kubelet knows the information about the pod is marked as not ready. And this might be a problem for this API, because if someone relies on the kubelet that, let's say, kubelet is right now source of truth for post readiness, we need to know that when we return the data, they are actually computed by the kubelet, not that they are just set to default because kubelet is in its initial state. And this issue needs to be resolved this way, that I think that we can attempt it on different approach in 2 different ways, for example, but I think that we should also return the error state of this API. So we should detect that the kubelet is in this init loop that doesn't, for example, run first reconcile loop and does not know all of this information about the pods. And this information is, let's say, returned in the API. So if someone call get or list on this API, the error code, which is well defined, will be returned. The other approach is to postpone running the API until kubelet is in this finish this init loop. So this is also some idea, but I think that the first one is better, because when API is not running, customers might be, I'm not saying frustrated, but might not, doesn't know how to handle those things, that the kubelet is not up. And for example, with this error, they know that kubelet needs some time to initialize, and they will try later. So this is our proposal to resolve this kubelet restart issue. Any questions? Okay, so another thing is control plane dependency. So our goal with this API is to limit the control plane dependency. That's why we would like to return the, let's say, most recent data. And when control plane is down, it should not, the API should be running and the data should not be impacted. So we will use some kubelet already existing cache, which is kubelet is, let's say, checking the different condition for pods, like readiness probes, and stores those conditions in some local caches. I think it's status manager. And we would like to return the data with our API based on those data which are in kubelet local cache. And I know that kubelet is reporting the every every time something changed within the pod, kubelet is reporting this to kube API, and it wants to be sure that with this API, even if the control plane is down, or for example, kubelet sends the let's say status or try to report changes for pod to control plane, but does not receive the response. We want to be sure that the data that actually computed, that kubelet knows that, for example, this probe is failing, but previous state was that it was running, and we want this API that it will return that the probe is actually failing right now because this is the actual state of the node. And like this, but like I said before, with kubelet issue restart, we know that the kubelet needs kube API to be running to know which pods. So this is the corner case of corner case that actually kubelet will return the error. So TLDR is that if kubelet knows the actual state about the pods, the system, it should be reported like it is, even if kube API is down. But if kubelet cannot find out about the pods or cannot, for some reasons, cannot run initial loop because the control plane is down, kubelet should return the error. Okay. Any questions to that?
All right. Any other questions for Katarzyna?
Yeah, if there are no questions, I'd just say I really appreciate everyone's feedback here. This has been good discussion, and the agenda itself has a link to the KEP issue. If you follow that through, there's a corresponding PR for the KEP, and we'd appreciate review, not just from SIG-Node, but also SIG-Arch. I know that the timeline, I think we're less than a month away from KEP freeze. And this is a fairly big new concept. So the sooner we can get reviews, the better we'll feel about it. So yeah, appreciate all the feedback on this one.
Okay, awesome. Thank you. Let's see. What do we have next?
Thanks.
Wojciech, do you want to talk about a summary of what we found from the PRR survey? I'll stop at this point.
Sure. Yeah. Hi, everyone. I think we want to quickly summarize this year PRR survey. It's like the fourth time, if I remember correctly, that we were running this survey. It was actually the exact same questions that we ran last year. And the answers were quite similar mostly this year. There were unfortunately a little bit less, like roughly 15 to 20% less responses, unfortunately. There are just like a couple things that are probably worth emphasizing.
You want to share anything? Did you want to share? You're not sharing anything. Did you want to share anything?
I'm not sharing. I guess you need to give me a permissions.
I just
or
did, yeah.
Maybe you can share the. I'm not sure if it's like worth sharing.
Oh, okay, all right. I can share just our agenda from yesterday. Fine. Go ahead.
Okay,
sorry.
Yeah. Yeah. So I guess the main things that are worth emphasizing is that operators are lagging a little bit more than with the versions, both for the newest versions of for the newest cluster version and for the oldest cluster versions. Our suspicions is that it's probably because of deprecations. Like 121 is in particular the version that is like still heavily visible. And there were a lot of deprecations in 122, and we guess that it's probably because of that. It's somewhat similar also to the newest version, but it's again like 124, for example, Docker shim deprecation. So that's probably explainable. The difference is visible, but it's also not super huge. So we hope that it will it will improve over time too. Rollbacks are another thing that is probably worth mentioning. We had a little bit less rollbacks as a percentage of people who said that they did minor rollbacks in particular. What is a little bit worrying is that like we've seen rollbacks, minor rollbacks because of cluster failure, like, but we didn't see them like the last year. But also, if I remember correctly, there was like 1 or 2 those responses, so it's not also statistically significant. I'm personally happy that we finally didn't have any like rollbacks because of scalability in production, but that's probably not the most important thing. What is important is that there were no rollbacks. No one said that they rollbacked patch version in production, so it shows that like really the quality of our like patch versions is really improving over time. It wasn't the case like year before. For beta features, there was a little bit more people disabling the beta clusters. But on the other hand, like the primary reason for this disablement was that just only that feature didn't work, which is basically what we want to have if people are really disabling the feature. What was it's probably the most worrying thing from the survey was that like way more, like roughly 2x more people were actually enabling alpha features in production, which is pretty surprising. And we want to follow up a little bit on that with those people, but it's still like an action item on us. But I guess like one thing that is not written here is that 70+% of people said that yes, Kubernetes is more reliable than any year before, and another like 20%. So like it's saying that they are not sure. But even those, like there were like a couple, like 2 or 3 people saying that it's not more reliable than any year before. But at least one of those were saying that it's not more reliable because it was pretty reliable even before, so it can't be more reliable now. So basically, it clearly shows that we are going in we as a whole community are going in the right direction. And I guess like our summary is that one of the reasons we were running this survey is to show or to prove that the work we are actually doing with the PRR, the whole PRR sub-project, actually makes sense, and the cost of requiring every single person to fill in the PRR and our cost to review it and approve it, it actually makes sense. And the conclusion is that yes, we believe that it actually is worth it. We want to continue it. We didn't yet decide if we will run like this survey again, probably not in the same format, and definitely not to prove again that like our effort makes sense. It's more like we may decide to run somewhat similar survey, probably a little bit more updated to find if there are other directions that we want to improve more. Upgrades and rollbacks and understanding a little bit more the problems with those might be one of the things that we want to explore, but this is something that we will be discussing over the next months before. Because if we decide to run this survey, it will happen probably around like Q2 next year, so we still have a little bit time before then. Yeah, I guess that's the high level summary. John, I don't know if you want to add anything.
No, I think that's it. So if there are any questions on that, or we can share the overall results as well if people want to look through the reports. All right, last item here, Rian.
Thanks, John. Just some reporting on where we are with the conformance project. there is a E2E test that has done its 2 weeks flake-free, 13 endpoints. So we're going to promote it on our Monday. So when you get to the office on Monday, you'll have that ready for approval. There was, however, one flake in the first 24 hours of the test running, but that is linked to a known bug with a webhook admission test. And that is actually interfering with tests all over the test suite. So, and we thoroughly assured that is the problem. There's nothing else to block it. So if anybody noticed that. Then there is a new test with 7 endpoints that I discussed this morning with SIG storage. Already got an LGTM there, just waiting for approve. And when that's done its 2 weeks, we'll come back for approval on the promotion. So that's 20 endpoints already for this release we're looking at.
Awesome. Okay. Thank you so much. Any other items for discussion? Okay. Well, why don't we get back 20 minutes? Thank you all. Thank you, Katarzyna, for the all the details on the Kubelet API, and we'll looks like maybe she dropped off. But anyway, we'll see you all later. Thank you.